Hello everyone and welcome to this video. Today we are going to be learning about NumPy comparison operators, okay? So as I told you, we're going to learn about NumPy comparison operators, okay? So this is going to be similar to normal Python. So if you already know them, you can probably you'll just have a little revision of the comparison operators in Python, but the only thing that's different is the way that it is presented. So that is what I'm going to cover in this video, how to kind of analyze the way it's presented. So let's go ahead and launch our Jupyter Notebook, okay? So what you want to do is you close that and you type in Anaconda prompt if you are in Windows, and terminal if you are in Mac or Linux. So I'm going to press Anaconda prompt because I am in Windows. So bring this over to here and zoom in because I want you guys to see. So what we're going to do is we want to activate our environment using Conda. But before that, just a precaution. If you have not set up your environment yet, please do so. Otherwise, any of these commands that you type will not work and you won't even have Anaconda prompt, okay? So please do that and let's actually start typing. So what we need to type in is Conda activate users. So you just need to specify the file path. So this is my file path. Make sure you type in everything correctly, so you don't have to type it again. So ML course, practice project, and okay, let me zoom out. Okay, so there you go. And then we press enter, and then we type in Jupyter Notebook to launch our Jupyter Notebook. And it will start coming up with some URLs and links, and there you go, it's come up, and now it has launched, okay? So let's wait for it. And it should come up with a homepage, okay? So now what we're going to do is we are going to navigate using this path that we typed out and find our Jupyter Notebook. So let's do that. Okay, so here we are. And this is where we left off last time, where we learnt about the dot product example. So we looked at a dot product example where we had to recreate an array, but there were little issues in between, so we had to use the dot product to do this, okay? So today, what we're actually doing is we are actually still going to dive a little bit deeper into manipulating and comparing arrays. So as we are doing that, we have manipulating and comparing arrays. So today we're going to learn about comparison operators. So it is within the manipulating and comparing array section. I'm just gonna write like this. Manipulate did I spell that correctly? Manipulating and comparing arrays, and today we are learning about comparison operators. Okay, so we're going to turn that into markdown and run that, and we have our title. Okay, so yeah, it's manipulating and comparing arrays. So as I told you, we have comparison operators, okay? So they are similar to Python, yeah? So first we're going to bring up our arrays, A1 and A2. These are very useful NumPy arrays. So we got array 1, 2, 3 and array 1, 2, 3.3, 4, 5, 6.6. So the first comparison operator we are going to use is greater than, I believe. So we're going to use this symbol, okay? So we're going to say A1 is greater than A2. So let's see if that is the case. So it's giving us all as false. So now why would it give us that? So you might want to analyze this. So basically what it's trying to say here is, so first we're going to check if 1 is greater than 1. No. So 1 is actually equal to 1. Is this 2 greater than 2? No, it's equal. Is this 3 greater than 3.3? No, because 3.3 is larger than 3. And here we're saying if every element in A1 is larger than every element in A2. And after that, all of these elements are smaller than all of these elements. So it is correct for all of these to be false. So we can also try the smaller than operator. So we can say if A2 is smaller than, if A1 is smaller than A2. And first it'll give us these ones, these two are false, because if we look at A1 over here, it says 1 is smaller than 1. No, it is equal. 2 is more than 2. No, it is equal. But then 3 is definitely smaller than 3.3, so that would be true. And then these 4 numbers are larger than these 3 numbers. Not 4 numbers, sorry. These 3 numbers are larger than these 3 numbers, so obviously it would be true, because these 4 elements in A2 are larger than A1, and here it is saying if A1 is smaller than A2, so that will obviously be true. So let's store this in a Boolean array. So we're going to say bool array. So a Boolean is the fact of true or false, and this is all we're getting, true and false. And then after that, let's call our bool array. So bool is short for Boolean. So once we call that, we get our array. So let's check the type of our Boolean array, although we already know what it is, but we're going to check it anyway. Type bool array, and you get a numpy.nd array. Let's check the bool array dot d type. So it will give us the data type of the most so it will give us the most common data type of each of these elements. So the data type of the elements here is Boolean. So it's false, and it's either false or true, so those are Booleans. Okay, so let's try a few more logical operators. So let's ask if A1 is greater than 5. Okay, so that is obviously true, because if we check A1, 1 is more than 5. So obviously it says all false, so because 1 is smaller than 5, but here we're asking if A1 is greater than 5, and 2 is smaller than 5, and 3 is smaller than 5. So this answer is correct. Let's check if A1 is smaller than 5. Obviously that is true, because all of these values are smaller than 5, okay? So there is also another operator called equals operator. So let's say if A1 is equals to A1. So 2 equals this time. So let's check if that's true. Obviously it's true, because A1 and A1, they're both the same. They're not different. There's only one A1, but we're just asking if both of the kind of A1 calls are same, because if we call A1 and A1, they're both the same, so obviously it will return true. Okay, so we can also see if A1 is equal to A2, and the first two values are true, because if we look here, we check A1 and then we check A2, and we look at this. So 1, 2, 3. So 1 and 2 are the same. 3.3 is not, and these two aren't either. Okay, so those are literally all the operators you can think of. There are also like certain operators specified to NumPy. So instead of like just these symbols, there's like actual words. So we can search up NumPy comparison actually, let's search up here. Numpy comparison operators. Okay, so that is what we're going to search up. Numpy comparison operators. Enter, and as you can see here, there is a result saying logic functions. Okay, so we're going to click that. So obviously this is an old one, so we need you need to get the newest one you can find. So these are called logic functions. Okay, so we have got comparison. So let's look at the comparison one. So it says array equal true if two arrays have the same shape and elements, false otherwise. So let's try array equal. Let's say array equal. Shift tab to see what things we need to pass in. Okay, so so it's not it's not giving us a documentation. So what we need to put in is, let's put in A1 and A2. Whoops, name array equal is not defined. Let's see what has happened here. Maybe it's A1 dot array equal. Let's see that. Okay, so numpy.nd array has no attribute array equal. So right now it's thinking it's an attribute. So we tried, but it didn't really work. Okay, so don't worry if it didn't. We still have these Python operators, but it's always good to try. So there's also a greater. So if we look at the array equal documentation, actually, so these are the input arrays. Whether to and equal NaN, whether to compare NaNs as equal. If the D type of A1 and A2 is complex, values will be considered equal if either of the real or imaginary component of a given value is NaN. Okay, so this will obviously return a Boolean. Okay, so what we need to do is we need to say np dot array equal, and let's pass in A1 and A2, and we get false because the element and the shape is obviously not equal, so it will give us false. Let's look at a few more. So let's go back. We've got greater, so yeah, so also there are a few more operations I wanted to teach you. These are the simple ones. So sometimes you can combine like this symbol and the equal signs together. So you could say if A1 is greater than or equal to A1, this will obviously return true for some reason, okay? Because it says greater than or equal to, and A1 is obviously equal to A1, so it will return true. So we can also say this with A2, so A1 is greater than or equal to A2, and it will give us true, 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 false, 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 because if we look at A1 and A2, we get, so 1, 2, 3, they are equal, and then the rest is obviously false. Okay, so you can also do it with smaller than, so you can say if A1 is smaller than or equal to A1. Okay, so that's I can expect that because A1 is obviously equal to A1. You could try if A1 is smaller than or equal to A2. So it'll give us true, 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 because the values in these first two values, they are equal to A1's values, as you can see here. 1, 2, 3 is equal to, and then we've got 1, 2. So 1, 2, and 1, 2 are equal, and then the rest, so 3 is smaller than all of these, so it'll give true. Okay, so those are all the logical operators I wanted to cover you guys on. If you guys have any doubts on these logical operators, I will put the actual documentation if you like, so you guys can go check the NumPy logic operators too, and these and also maybe the Python ones. Okay, so if you like this video, please like and subscribe, and thanks for watching this video. Bye.